In high available system, we are referring to a class of application and system that they can withstand a measure of degradation while remaining available, which means they are at very minimum of downtime and they don't need a regular human intervention. And their ability to self-heal or to recover from failure or even to roll over to another secondary source in an acceptable amount of performance. Now, those percentage of uptime and percentage of downtime, we use them to basically classify a service, whether the service is 5 nines available or 2 nines available or 1 9 available. For example, if we describe a system to be 4 niners available, this means it can be accepted to be down for the maximum of 52 minutes and 6 seconds, which equivalent to or equal to 8.6 seconds in one single day. We could use elastic load balancing that distributes incoming application traffic across multiple EC2 instances and containers, IP addresses, and Lambda function. So keep this in your mind. Even if you have a containerized application, still you can use elastic load balancing. Those elastic load balancers, they can be external, operating at the public subnet, and they can be internal, operating at the private subnet, which means the user or your end user, they won't be able to access them from the public internet. Each load balancer receives a unique domain name system, and it can be recognized and responds to unhealthy instance. Because load balancer, once it's looked to the target group of the load balancer, it can tag each instance which not responding to the healthy check to be healthy or unhealthy. Unhealthy instances in load balancing, as you know from Lab 6 in the Cloud Practitioner, it's going to be replaced by a new instances with the help and aid of autoscaler. In AWS, there is 3 types of load balancing. There is the application load balancer, which operates with HTTP and HTTPS protocol. It's very flexible for application management, and it can use an advanced load balancing of the traffic via HTTP and HTTPS, and it's normally operate at the request level or layer 7, which is the application layer in the OSI mode. With network load balancer, we are looking now to an extreme performance. And remember, network load balancer only operate at layer 4, so you need to operate network load balancer with the TCP traffic straight away. It's not going to operate at the application layer. It is a very ultra high performance, and with support of static IP addresses of your application, it can load balance TCP, UDP, or even TLS traffic and operate at the connection level of layer 4. If you have an old application or an old infrastructure which needed a load balancing of both application layer protocol and layer 4 protocol, then you need to look at the classic load balance, because the classic load balancer will operate at HTTP, HTTPS, and it also support TCP and secure socket layer traffic as well. It can load balance across multiple EC2 instances, and it operates at both the request level and the connect. You can implement highly available system when you have the ability to start with at least 2 availability zones. If the first resources in the first availability zone goes down, then with the aid of load balancer, you can redirect your traffic to the resources that you have in the second availability zone. And this is a good example of a highly available architecture. As you can see, we have an internet traffic coming to the internet gateway, which will be redirected to the elastic load balancer. The elastic load balancer will distribute the traffic between those EC2 instances in the multi-AZ, depending on how busy and how capacity each one of them is getting. So it's most likely is going to split the traffic between. Then you can have an internal load balancing, which can redirect the traffic from your web tier to your application tier. In the same way, it will distribute the traffic in an even way. This is an example of a highly available architecture where you can use the elastic load balancing for your own benefit. And now let us look to Amazon Route 53. Amazon Route 53 is a highly available and scalable cloud DNS service. It can be used to translate a domain name, for example, like AWS.com, into an IP address, which is the main public IP of the web server. It can connect your user request to your infrastructure and can be configured to route traffic to healthy endpoints, or even to make sure that your infrastructure are running in a healthy state across multiple regions. It can also help you to register and buy your domain, and it has multiple routing options that you need to understand for your exam. Amazon Route 53 supports multiple routing policy that we will describe now.
In Route 53, there is multiple supported routing, and we are going to explain each one of those in details because they are very important for passing the exam, both exams, the solution architect and the cloud practitioner. So the first thing we want to do is to see how we can create a domain name in Route 53. So let us now go and create a domain name, and I will show you how you can create a domain name for your business and for your organization if you need to have a domain name. As you can see, now I am in the management console and I want to go to Route 53. Once I go to Route 53, now Route 53, if you go to the dashboard of Route 53 and you click on Get Started, it will give you all the starting points that you can use to create and to work with Route 53. Now let us say I have an organization, I want to call it AWS Training, and I want to register a domain name for that organization. So I'm going to select register a domain, and then we will click on Get Started. Now it will give me a list of all the available domain. You can choose the prices per year depending on your need and depending on your extension. Let's say I'm going to call this Academy. So I'm going to call this AWS Training, and this will be a domain name .academy. Okay, now I need to check that this domain name is available. If it's not available, it's going to propose different domain names that I could use. It seems to be awstraining.info, but maybe it is a bit expensive. So I'm going to change this to something else. Let's call this free AWS training. So this is going to be a free AWS training. You could call it based on your business that you want to create a domain name for. Now you can see freetraining.net. It will cost me $11 per year. So I could add this to my cart and then I click on continue. And then you specify the details of your payment information to whom this business and domain will be registered. So normally you need to provide your addresses and you click on continue and you check it out. Now the next thing I want to show you is basically how we can create a health check. So before we do that, let us have a demo application. And in this demo application, I'm going to use a simple format for my application. It will be an EC2 instance running a simple web server. So let us go now to EC2, and I have it here running on a different system. Let us go now to the EC2. And if you go to my EC2, you will find that I have a demo application running, which is the same cafe application that we used and we use in all of my labs and all of the AWS Academy lab. Now this instance is running on this public IP. So if you open this in a new tab, it will give you a hello from a web server. And if you basically pop this extension, which is a mom pop cafe, you will find the same interface that we used. And as you can see here, the IP address of my EC2, and it is available in US East 1A. Now, what I want to do is to create a health check from Route 53 because I'm not sure that this instance is healthy. And once it's not healthy, I might just get an alert to my email, and that alert will be sent so I can basically have a secondary hosting zone for my application in S3 as a static website, for example. So let's go now to Amazon Route 53 from a new tab because I want to keep the EC2 instance to show you later on what I'm going to do with that. Now there is, in this particular environment, I have a domain name registered. I'm going to use this for testing and to demonstrate the different routing that we have in Route 53. Let us go to health check and we create a health check. I'm going to call this primary, and this primary is going to check an endpoint, and that is the endpoint that I'm going to check here. So I'm going to go back select endpoint, it's an IP address, and the IP address of my EC2 instance, I just need to copy it from here. Now this is going to be my instance IP address, and the slash path is going to be, because I always reach my website using this slash path, so I'm going to basically put the same here on the path. So I'm going to go back and paste. Now in the advanced configuration, I want this to be fast because I want to show you this as soon as possible. And the failure threshold, which means Route 53 will declare this endpoint unhealthy after 2 failure of health check. You could also include latency graph, and you could basically have a customized matching for your string if you are using an API. We will see this later on with the API gateway. Click next, and we want to create an alarm, and we want to send this alarm to our email address. This is going to be the channel email address that we use for most demonstration. So let us go back now to our email system, and we basically have an existing SNS. We are going to create a new one, and we will call it primary EC2 down, just to let me know that this is not healthy and I wanted to send it to this email and create a health check. Now, after a few minutes, you should be able to receive a notification to your email address saying that you have to subscribe to this topic. Wait for a few minutes until this can give us a value or to show that there is unhealthy instances. So let us wait a few minutes now. We will receive an email to our email address. So I received the email that I have to subscribe to this topic in AWS notification SNS service. I will confirm. This is all you need to do, guys, just to click on confirm. Now let us test that this thing is working. We will go to the instance state and we will stop the instance. Maybe accidental deletion of the EC2, maybe an accidental stopping of the EC2, or a crash of the web server. I want to make sure that I will receive an email that telling me my EC2 is not available and my customer cannot see now the website. Could see now this is going to give me 505 very soon. So let us wait, and once I receive the email, I will share it with you. As you can see now, the EC2 instance is giving me site cannot be reached, and I will wait now for this notification to arrive to my email. Now, how we can prevent that in Amazon Route 53? This is what we are going to discuss in the next topic. We have to create what we call Route 53 routing policy. And the routing policy prevent an accident like this to happen in our infrastructure. And as you can see now, I receive an email saying that your primary EC2 instance is down, which means I have to go back and I will make sure to start and to reboot the instance. Now let me just refresh the page. Now I have another instance here. We are going to use it in the demo. We will see that this machine is fully started. So as I said, to prevent such scenario, we have in Amazon Route 53 multiple routing policy. They are supported in Route 53. And we will discuss each one of them, and I will show you how you configure each one of those in the management console. We have the first one, which is simple routing. It has a single server environment with single domain, and you want to basically tell Route 53 that my domain name, www.baz.ie, awstraining.ie, or .com, is pointing to this IP address, as simple as that. So let me show you how we can create simple routing. So with simple routing, we have a single server environment. We have our primary, which is an Amazon EC2 instance here. And we are just pointing the record, which is the www record, to a type A record to this IP address. This is what we mean by simple routing. So let me show you how you can do that. I will keep this health check there because we will need it later on. You go to the hosted zone and you will find that this record created once we register with Route 53, our domain. So we're going to select it and we will create a record. It will be a simple routing. Click next. Now I want to define a simple routing. It will be www for this domain name here, which is the domain name I register. It will be record type A, and now the endpoint is going to be an IP address. And what is my IP address? I want it to be this EC2 instance here, the first instance. Go back, paste it, and define a simple routing and create a record. As simple as that. Now, once you put and you copy this domain name, instead of accessing your website by accessing the IP address, I want to be able to access it via the domain name, which is what Route 53 gave me. In specific, I want to be able to access this cafe website with all the information. As you can see here with simple routing, this website now is served from the EC2 instance in US East 1A, and this is the IP of the EC2 instance. Now the second type, what we call weighted round robin routing. With weighted round robin routing, I have a primary EC2 instance in the first availability zone, and I have a secondary EC2 instance in the second availability zone. Now, normally with Route 53, we do this cross multi-regions. Why? To guarantee that we have a decent disaster recovery. And the point here with weighted round robin is very simple. We want to split the traffic based on the weight. So 75% of the traffic, I want it to come to the first EC2 in the first availability zone, and 25% of the traffic, I want it to go to the second EC2 in the second availability zone. Let me show you how you can do that. Let me delete this. And make sure when you create a domain name in Route 53, don't ever delete the NS and the SOA records. This is the domain name system that you will use with your domain when you register, and this is the authoritative record of your domain name system. Both don't ever delete them. Let us now create the weighted. In the weighted, it's going to be the same. The record name is going to be www, and the record type is an A, which means it's an IP address. Could also specify a DNS, other DNS information. You could also specify Elastic IP, Elastic Beanstalk, or Elastic Load Balancer DNS name. Could also specify S3 bucket if you have your website in a static website hosted in S3. Now we want to define the weighted record. So the first definition, I want the first IP address, which is, as you see here in this diagram, 54.225.17.0. I want it to take 3 out of 4 traffic. I want it to come to this EC2. And 1/4 of the traffic, I want it to go to this EC2. So I will go back, copy the IP address of my EC2 instance 1 and paste it here. The weight is going to be 3, and this will accept a value between 0 to 255. I have a health check, which is the primary, which can basically help a lot when we define this. Now we need to specify a record ID, baz, let me call this, and this is going to be W1. And let me define another one. It will be an endpoint, but this time I want that endpoint to take the traffic to my second EC2 instance, this IP, and the weight of the traffic, I want it 1 out of 4. The health check is not going to be any health check because we don't have health check associated with a secondary instance. So we're going to call this again baz-w-2 and define, and then you will click on create. And this will create a health check for you. Now this means if you go to your website, most of the traffic will be served from the first availability zone. Unless there is a very busy traffic going to the availability zone A, then you will be routed to the second availability zone. This is very handy when you have, for example, a pilot line disaster recovery, you have a tiny EC2 instances to support your system, and you have your main infrastructure on a premise data center, and you want to make sure if there is any issue with your primary to route everything back to the secondary. Now let me go back and show you the next one. But first, let us delete those. You have to delete them. And this time, I'm going to show you the latency routing. With latency routing now, Route 53 will decide how to send your traffic based on the latency value we are getting. So if we have, for example, a latency of 125 milliseconds going to the primary EC2, then Route 53 will use this link because the secondary is giving us 225 milliseconds. How we can define this in Route 53 based on the latency? Very simple. Go back, create a record, choose latency routing, click next. It is again WW. I have an A record type. You could also put the TTL to 15 seconds instead of 300 seconds in order to fast test this configuration. Define, it will be an IP address, and the same thing we will do. We have an IP address, the primary IP address. Go back, paste it here. In which region? Because the latency record need to test based on the region. Now, if you notice here, I am in North Virginia, so I go back and choose North Virginia. I think you should put US first. North Virginia. I have a primary health check because this is from where Route 53 will get the latency value. It will get it from the health check that we do. Let me call this BAS-L-1. Then I will add a new latency record. The same thing is going to be for the same region. Now, normally, as I said again, normally we will have two different regions to deal with Route 53. So I'm going just to copy the same IP address that I have in my second ability zone. And I did no control over this, guys. If I have permission, I will create two EC2 in two different regions to demonstrate this better. And there is no health check associated. Again, this will be BAS-L latency-2, which is record 2. And then you click on create. Sometimes these records will now with geolocation routing, I want a very simple configuration. I want, based on my customer base, I want to route them to my primary or secondary infrastructure. So in this case here, I want the Indian user, my users in India, I want them to come to the first primary zone, the primary host, the first EC2, and the Irish customers, I want them to come to the second EC2 in the second ability zone. In the same way you do this, you go, you create a record, and you choose geolocation, you put www, and now the record is A again, and you define geolocation. You choose the endpoint. As I said, the first EC2 instance 1, I want it for my customers in India, and you could choose a continent, you could use a specific country. I'm going to choose a specific country just to show you guys how this is going to work with the primary, and this is going to be BAS Geo 1212. Hopefully nobody's using the same record ID. And then I want to define another one for my Irish customer. This is going to be the second EC2 instance IP address. I come back here, paste, and this will be Ireland, and no health check. And this is going to be BAS Geo demo and 3343, for example, and define and create. This is created successfully. Now let me show you. So I said my Irish customer and my IP now in Ireland. So I should be reaching to this EC2 instance 44, which is in my second ability zone. So if I refresh this page, I'm not using the record, guys, and that's why I'm not getting the right value. You need to go to this link here, / and you can see I'm getting the response from 1B. Let me show you now. Let me connect to VPN to India. Now this is a VPN just to test. It's a free VPN, guys. You can use it just to test. Okay, so my VPN connection is active. Now let us test. As I said again, my Indian customers needs to come to 54.22255 as well. So if you refresh the page, now you will be asked to go to US East 1A. Again, guys, normally we do this from multiple regions. So that was geolocation. Thing I'm going to demonstrate is failover. And failover is very simple concept. With failover routing, I want to make sure if my primary EC2 instance is down for any reason, I want to fail over to my EC2 in the second ability zone. Now, normally, if you can't afford, depending on your disaster recovery plan, what you could do is to create an S3 bucket, and it will be your secondary hosting of your website just to display a nice message to your user. So let me show you how you can do failover. Now remember, you have to have a health check for failover to work in a proper way. Go to the create record, and with failover, click next. And this will be www again with, let me put this 15 seconds because I want to show you this in action. And let us define a failover. First is going to be my primary, the record type, and the primary IP I have is this IP here. And the health check is a primary. And again, let me do BAS failover, and let me give a value. Now the second failover is going to happen in the secondary, and in the secondary I don't have a health check. Okay, so there is no health check here, and this is going to be BAS-7788 and define. Oh, I forget to paste the IP address. So let us go copy the IP and we paste it here. I'm sorry that this video might be very long for you guys to see, but I will leave the timestamp so you can basically go to the section that you are interested in the most. Click on create record, and now my record is there. Let me show you this in action. But before I do anything, I want to go back to my health check and open it in a new tab. It was 31 minutes ago when I basically turned off the EC2 instance, and then it came back down. Now the health status is okay. You could also see the latency. The latency was about 100 milliseconds for TCP connection, and this is basically will work, and it will be actively routing the traffic between your multi-hosting and multi-region based on the latency. So let us go and test the latency. We'll go to the first EC2 instance and we will stop. You will get an email similar to this one, and immediately your EC2 instance will be routed the secondary record to your second EC2 instance. So now this is fully stopped. Let me check. Stopping still. Let me go to my website now and refresh. I am in 1A, notice that, and now it should be changing me, failing over automatically to the second EC2 in the second region or in the second availability zone for our demo. But in general, you should do this infrastructure to different regions. Now remember, I put in the health check, I put 15 seconds, and also in the configuration in my record, I also put the failover with 15 seconds. Just to keep this in mind. The TTLS is basically time to live, how much your content will be cached in the Route 53 cache. So if you want a fast response, you want to have a smaller value if you are just testing. But for production, you normally put a higher value like 300 seconds. Let me go back now. It is not available. It was declaring the first primary hosting of my infrastructure is down. Send me an email and automatically Route 53, it failed over to the second availability zone of my infrastructure. The last thing I want to show you is multi-value, and hopefully this will not let me down and it will work. Because with multi-value, I want to configure a method in Route 53 to give a different DNS answer for every single request. And this is to avoid a single point of failure, any hacker who trying to reach and to find out the final IP address of my infrastructure. So let me show you how you do that. Let me delete those first, and now go back and create a record, and it will be multi-value. Click on next, the same configuration, www.a300, and define multi-value answer. It will be an IP address, and the IPs that I have, let me turn on this machine first. I have this IP for my region, and I want to get the IP of this EC2 instance in two separate lines will be possible. I could assign a primary check. And with health check in a place in multi-value, it will use the first record. So it will be good idea now if I keep my primary EC2 IP address in the top. Show me this in multi-value. So I'm going to choose a record and define and create. Let me edit this and define a second one for my second AZ, and this is not the primary. MU of 889, define and create. It works magically. I'm delighted. So look back now to my website. You need to refresh this many times to see an effect, and now the multi-value answer will start to be in a place with Route 53. So Route 53 start to give you different responses based on different answers. So let me, for example, open this in a private session. I think my VPN is still in a place, and in the cache, my VPN is connected, and that's why I'm getting this bad multi-value answer. Now I should be routed back again to US East 1B because my VPN enforces, and the cache of Route 53 keep telling Route 53, give him the first availability zone. Give him the first availability zone. He is requesting the websites from India because geolocation route. With Route 53, you need to work very slowly, and you need to allocate enough time to test and to do the experiment. But just to keep this video very short, I'm trying to do my best to wrap it up in this short demo. So you can see now, using another browser, I'm getting answer from US East 1B. And this is without VPN, guys. From this browser, I'm getting answer from US East 1A. So this is the point of multi-value answer. So this is pretty much what...
And the implementation of Amazon Route 53 is to basically use it as a cross-region availability. So it will make sure that your infrastructure that is deployed, for example, in a region A and region B are highly available. As you know, Amazon Rules 53, using a failover technique, it will keep sending a health check to your infrastructure in the region B and region A. Within a specific time frame, if they get back no healthy response, they will redirect the traffic of all users from region A to region B. So they start to not use region A to accept any traffic. Now let us look to the first guided lab, which is creating a highly available environment for the cafe. In this particular lab, you want to go and inspect a VPC, create an application load balancer, create an auto-scaling group, and test the application for high availability.